Okay, now, I have commented, you don't want to use a calculator in approximating these things. Because when you have linear equations, they can be very sensitive to round-off errors. Okay? Now, I'm not going to say much more about that. Maybe we'll run into a case where I can illustrate that, but I'm not going to intentionally do that. Okay? It just, you got to be really careful about it. Okay? So stay away from approximations if possible. So here are my equations, right? Okay, now I'm going to do a couple of things. I really don't want to be dealing with decimals, because that might tempt me to go to my calculator. Well, if I multiply both of these first two equations by 10, then I don't have any fractions or decimals at this point. Now I'm going to end up with fractions. So I'm going to get 9s plus 2d equals 10s, and s plus 8d equals 10d, and also s plus d equals 1,000. Okay? So that's my first operation on the system. I observe that all my variables are linear. Okay? So now I'm going to rewrite both systems. In the form that's much like what you would do with the flow model, like something times A plus something times B plus something times C equals something, right? So to get all my variables on one side and in the same order. Okay? So here I can write this as negative s plus 2d equals 0, right? Okay? And I can write this as negative s minus 2d equals 0. And then I can write s plus d equals 1,000, right? Now, there are a couple of possibilities because all three of these equations have to be satisfied, right? It's very possible to write down three equations that are inconsistent, where the solution to the first two doesn't work in the third one, right? Like if I make one little algebra error here, I'm going to have an inconsistent system. Okay? So my question here is, are they consistent? Because if they aren't consistent, there would be no solution. Okay? And then you're not even assured that if they're consistent, you have solutions. Okay? Actually, you are assured. But you're not sure you have a unique solution. For example, if you look at the first two equations, you can see that the second equation is really the same as the first, isn't it? Just change the signs and it's identical, right? Which means that there are infinitely many solutions. Because if s is equal to 2 and d is equal to 1, that's a solution, isn't it? If s is equal to the square root of pi and d is equal to if s is equal to 2 square root of pi and d is equal to the square root of pi, these two equations are satisfied, right? Okay? So I'm going to make a side note here that these are consistent, but infinitely many solutions. Okay? Just with these two equations. Now you add the third equation, and then you have only one of the solutions to these systems that satisfies this condition, okay? And you know what that is, you've already solved it. Make sense? Okay? So, these are things we need to think about when we're dealing with systems of simultaneous equations. Okay? So the question, is the system consistent? And then does a unique solution exist? If this was your system, yes, it's consistent. But no, there's not a unique solution. There are infinitely many solutions, not just one. Okay? And then there's a geometric interpretation of that in terms of planes and three-dimensional space that we'll talk about later. Okay? And it's simple enough to understand if you do something else first. Okay, well.
Explodes.
So how are we going to solve this system? Okay? Now, what most of you want to do is you want to do pretty much what we did before. You know, get S equals 2D and plug it in here and solve, right? We're going to do it by elimination. Just to illustrate how that works, because it's really important. Okay, are you ready? Well, it's easy enough. Okay, just to kind of facilitate things. I'm going to put this equation first. And these two equations. Again, it's very obvious these two equations are equivalent. But it wouldn't always be obvious, especially in a system with more variables, okay? So now I have equations 1, 2, and 3. So if I add the first equation to the second, I eliminate S, right? So the first equation plus the second gives me 3D equals 1,000, doesn't it? And I'm not writing out the details of that, and I'll go back and review what I did before if you're not sure what I'm doing here. But this tells me that 3D, I'll say 0S plus 3D equals 1,000. Okay? And then, well, if I add the second equation to the third, what do I get?
You eliminate D.
What equation do I get if I add this to this? I get 0 equals 0, right? Anything wrong with that? Is it true? Well, there's nothing terribly wrong with it then, is there? Now what if I got 0 equals 10? That's false. That means that my system ended up giving me a false statement, so the system doesn't have a solution. Okay? This is okay because it's true. If this is a false statement, then you're done. You have no solution. Okay? Okay, well then, what am I going to do for the third equation? Well, we still have to have S and D in here, so S minus 2D equals 0. I don't do anything to the third equation.